It was really clarified in 1952 by this study. Nielsen and Smith in Copenhagen studied the interaction of hypoxia and CO2 on the regulation of breathing. At the x-axis, you can see this is alveolar PCO2. On the y-axis, it's ventilation in liters per minute. And the right-hand curve shows you that the ventilation with increasing PCO2 in normoxia is about 2 liters per minute ventilation for each 1 torr, 1 millimeter mercury rise of PCO2. It's pretty steep. In hypoxia, at a PO2 of 37, that's the left-hand curve here, this line shows the CO2 response is 5 times steeper with a constant oxygen at 37. But with mild hyperventilation, as PCO2 falls slightly below normal, the ventilatory response to hypoxia gets blocked. It remains constant and low. This sudden bend in the CO2 response curve is called a dog leg. And everybody knows that, but I call it the deadly dog leg because it is responsible for the deaths of the zenith balloonists and the fighter pilots who died because even mild hypoxic hyperventilation blocks the carotid body, and it doesn't take a lot of hyperventilation to do that, and it causes a euphoric death. So that's the most important message of this whole lecture. Well, that's the flat part that I call the deadly dog leg. In 1961, Tom Hornbein, an anesthesiologist that most of you know about it, showed that the carotid chemoreceptor nerve output rises semi-hyperbolically with falling oxygen tension. Lahiri and Delaney found that in cats, every single neuron coming from an individual cell within the carotid chemoreceptor is sensitive to both hypoxia and CO2. So this whole fan of curves can be determined from just a single neuron by changing the oxygen level. That's what the numbers are at the end of each line. Those are PO2 numbers. And this is a CO2 response, and as you can see, it just gets very much steeper in hypoxia. And what they did not demonstrate in this study is the deadly dog leg because they did not manually overventilate the cats. Well, in 1972, John Weil in Denver generated this hypoxic or hyperbolic equation that approximated the human ventilatory response to hypoxia. For many years, I had been reporting hypoxic chemosensitivity as delta V40, the isocapnic increase of ventilation in hypoxia at a PO2 of 40 torr. Typically, in normal males, that was about 25 liters per minute. This nomenclature became obsolete quite quickly, though, when hypoxic ventilatory response was found to be a linear function of saturation instead of PO2. Made it easy to measure by pulse oximetry, which came to be usable about a decade after Weil did his study.